Hi everyone, welcome back to CSharpCorner live show. As always, I'm your host Stephen Simon, and we are back with another episode of Ask Me Anything show. Can you imagine episode number 33? I'm kind of getting very delayed with this show. I don't do much often because we have been doing so many other live shows and partner conferences and events. So I'm kind of busy with that. But we are back again with AMA. It's been a while, almost like after 2 weeks we're coming to the show. So welcome everyone. Welcome back to CSharpCorner live show. If you're someone who is joining us for the very first time, I'll do a quick reminder that I always say that we stream 8 days in a week because we do so many. So every Monday we do Azure AI show that's both hosted by me, where we talk about the Azure AI ecosystem. We talk about different cognitive services and all that Microsoft has to provide. Then on Wednesdays we feature our C# Corner MVP show, where we feature the community leaders on how they started their MVP journey, followed by a technical session. Then on Thursday, we do Ask Me Anything, as it is today, Thursday. Then on Fridays, we do growth mindset shows. That's at 12 a.m. Eastern. We changed the time. I think we at season 2, where we're talking about how you can go ahead and build better softwares. That's hosted by Mahesh Chand. Then on Saturdays, we have Rocking the Code World with Dotnet Dave. I believe he is at episode number 22. He has interviewed some of the really great speakers from the Dotnet ecosystem: Matt Stoyson, Caitlin Dollard, Kendra Havens, Scott Hunter. I think the only guy who's missing in his list is Scott Hansen, but I think he should be getting it very soon. So apart from that, we have a few announcements that tomorrow we have the IoT conference that starts at around 8 a.m. I think 7 a.m. actually 7 a.m. Eastern time, New York. So definitely go ahead and check out. We have speakers, and one of the really excited section that I'm excited is about the Project 15 from Microsoft. The founder itself, she's going to come and talk about how the project actually started and the insights and how you can also go ahead and contribute to that open source project. Followed by that, on the Saturday, we have the Global AI Student Conference. I was just talking to Hank. He said that we have over 1,200 registrations on the platform. And apart from that, I just forgot to tell you a very interesting thing that in tomorrow's conference, we are giving away Microsoft Surface Laptop 4. Can you imagine that? Someone give it to me. I need it. So they're giving away Microsoft Surface Laptop 4. You just have to be very active in the conference, share it on social media. Yeah, that's how simple the criteria is. So that's all in the this week. In the coming days, we have conferences on Azure. We have conferences on .NET. Okay, hi everyone. Hi Sarvesh. Thanks for joining. Thanks for your time. And many more exciting events. So stay tuned at the csharp.live. At csharp.live, we add all our live shows and virtual conferences. So just hit that platform and you can find all the upcoming live shows. So hi, welcome once again, everyone. Please drop your location in the comments. It's always interesting to know from which location you're joining. You never know, well, your neighbors might be joining. You can go ahead and make friends in the live chat. Okay. So having said that, in today's AMA, right, I'm really excited to host Daniel. And Daniel is going to talk about the ML.NET, right? So I think ML.NET was released almost like a couple of years back, if I'm not wrong, and it is still new, but I believe it has matured a lot. So it's a pretty interesting topic to go ahead and cover today. And before I go and bring our guest, let me go ahead and read a quick bio for Daniel. Daniel is a senior software developer with over 15 years of experience, and he's a big fan of C# since his inception in 2001. So it means when it started, he actually started working with .NET. He's an international speaker in the field of .NET technologies, and he's spoken in over 40 conferences in EU and USA in the last 4 years. He's an organizer of ApexVox conference. That's great. That would be pretty interesting to talk about on what they're doing in the coming days. And he has taught over 700 students, and he's also a Microsoft MVP. So without any further ado, let's go ahead and bring our guest, Daniel Costea. Hi, Daniel. Welcome to the CSharpCorner live show.
Hi, Simon. It's a pleasure to be here. I remember with pleasure, CSharpCorner was like a lighthouse for me for more than 15 years, long before Stack Overflow. And yeah, it was like a extension of help from Visual Studio or something. But anyway, very useful during all this time. And thank you for inviting me.
Yeah, thanks, Daniel. Actually, thanks, Daniel, for accepting the invitation. It's always great to have you back. I think I'm hosting for the second time, so I'm really excited. And yeah, actually, C Sharp Corner is a pretty old website. As I read all their information about us, it started probably when I was born. That's how they started. So earlier it was known as .NET Heaven, so they kind of changed this to C Sharp Corner, something like that. So yeah, it's but thanks to all your readers and contributors who do for the platform. I think that's how we have grown in the past 2 decades. So Daniel, how are you doing? Actually, by the way, where are you joining us today from?
I'm joining from Netherlands. The
Hmm.
Hague is the city. I'm originally from Romania, but now I'm living here for the second year, and I
Yeah.
planning to stay a few more years. I have a job here now.
Okay, that's it. How's the weather? Is it like cold? Is it like what's coming? Is it like
Well,
summer still there?
it's getting warmer,
Hmm.
but yet we are waiting for the real spring.
Okay.
Because here it's very pleasant. The flowers are everywhere, and it's getting green, and it's a pleasure. Yeah.
Okay, that's great. Lucky you. Here in India, we have 45 degrees Celsius. That's close to 100 degree Fahrenheit.
Wow.
So it's very hot. So
Wow. Yeah.
Daniel, while I was reading your bio, all right, I just read that you are the organizer and the co-owner of the Apex conference. If I'm not wrong, here you're wearing T-shirt for the ApexVox, right?
Well,
So. Mhm.
we had two editions, but then the pandemic hit us like
Mhm.
everywhere else, and for now it's kind of on hold. We
Yeah.
will see if we will continue or not. But nevertheless, for me, it was an opportunity to meet big speakers and together to get together the community.
Mhm.
And now it's like pretty fine to do this online.
Yeah.
Everyone are migrating online, so I'm fine since I can talk about technology. I can listen to such wonderful events. It's fine.
Okay, yeah. So I think people have moved online, but I think people are definitely very desperate about the offline events, though, right? People really need that.
Yeah.
Uh, so with that, Daniel, as you say today, we're going to talk about ML.NET. But actually, when I go ahead and do a quick Google search for ML.NET, it tells me that it was released only a couple of years back. And I see you have been working in this field from back in .NET from 2001. So how did you actually go ahead and get started and working with the ML.NET ecosystem?
With ML.NET,
Yeah, yep.
I have prepared a cool topic for
Mm-hmm.
an event related to IoT, how
Mm-hmm.
we can deploy and run a .NET Core application on an IoT device,
Okay.
Raspberry Pi. And because the electronics was an older passion which I didn't developed enough. um, IoT was like, wow, another chance to meet electronics and uh, electronic components and sensors and LEDs. And of course, when I start to play with reading data from the sensors, very soon I got lots of data, and
Mm-hmm.
the larger the data, the bigger the chaos.
Yeah.
So kind of naturally, I have realized, okay, I have to get some meaning from this data, some information, and machine learning was the next natural step. And of course, I couldn't miss ML.NET because it was released, the beta released was in the same time, and I have joined these large and beautiful areas.
Okay. So that's great. I think so. You started actually with IoT. You saw that there's a lot of data that's coming in. So IoT devices definitely generates a lot of data. You saw that hey, this data can be used to go and analyze it. So actually, that's how you started with the ML.NET. right? So that's great. So that's great. So maybe let's go ahead and Daniel get started, and actually we could talk about what is actually ML.NET at the very first place.
What is ML.NET? First, I would like to add, I started with ML.NET and no data science knowledge.
Okay.
And that's very important because I'm supposing most of our audience it's developers, so
Yeah.
it's important. What is ML.NET? I will tell you a few things which is more relevant. Well, first it's a framework because you can follow some directions and use some libraries in order to build a model and to consume a model. So it's kind of complete environment to do machine learning. Even more, you can do deep learning with ML.NET. So it's not it's not limited to machine learning. But primarily, this is for developers. It's code first. And that means you can code every step there and build from scratch a model, and then as well you can consume it. And it's a cross-platform, and that's very good news because maybe it's not news. It's a fact which is very necessary nowadays because we want to run this on different platforms. For example, to mention only one of them, the ARM CPUs are more and more popular now with Apple doing this switch towards M1 CPUs. I think this was a last. If you need more reasons to invest in ML.NET as a development team, this was maybe the last and very important reason. Apple migrating to M1 to ARM CPUs. And of course, it's, for example, I didn't run ML.NET only for Windows. I usually run for Linux. So it's indeed a cross-platform. And another thing, it's on-premise. What that means, you can run in on your machine. You don't need a cloud. You don't need to send the data over the internet. It's running on the edge. So you can create your model on your machine and consume it. Maybe you are on the top of the mountain. Maybe you are on a IoT device. You can do all the stuff there. And for now, it's doing inference for deep learning models, but we are expecting soon to be able to do the training for deep learning as well, like a neuronal network. This is ML.NET, but I will get into some details soon.
Okay, that makes sense. You did say that ML.NET is open source, and you did say that you don't run just on Windows, and you primarily run on Linux, right? So, so when I think of ML.NET or anyone who comes from a C# background, they don't have to go ahead and worry about learning Python or maybe R programming language. They can use their existing C# and .NET knowledge to go ahead and start building machine learning models, right?
Yeah, well, there are 6 million .NET developers in the world, so we cannot expect all of them to learn Python only to consume ML.NET, a machine learning model. So it's natural to look around in this large .NET ecosystem and find something to build from scratch a machine learning model, and this is ML.NET.
Yep.
We have some other machine learning services like Azure ML or cognitive services, but this is code first for developers, and it's on premise.
Okay, that's great. Yeah, on premises definitely makes sense because some of the organizations don't would like to go ahead and put their all their training data to the cloud, right? So and you can just do it on your system. That definitely is a benefit. We have one questions coming up from Jose. If I say it right, he says, could C Sharp and ML.NET be faster than Python? Python is interpreted and C Sharp is JIT compiled.
Can you say again, please?
Can you read on the screen? I've added it on the screen.
Oh, okay. Let me. Okay. Um, could C Sharp and ML be faster? Oh, okay. Good question. Um, by design, it's faster because
Yeah.
it's compiled. And there is a white paper somewhere. If you search for ML.NET white paper, it will direct you right to the document. It's way faster than Python and than other frameworks because it's compiled.
Okay. So I think people usually one would usually think of it this way is because we usually use Python and R in for the data science, right? So this question comes obvious that hey, will it be as faster as now? Okay. So you said yeah, it would. Okay, let's take one more question from Arjun. He says, could you please guide me how we can use CPU while training model?
Yeah, there is support for training using GPU. You have to install additional NuGet packages, but indeed this is supported. And this is important, especially for deep learning scenarios. Machine learning, it's not very computing extensive task, not like deep learning. You can train machine learning in seconds or minutes, depending on the data, of course. But when we are talking about the learning, it's days or weeks.
Yeah, definitely, it takes a lot. I mean, even for the training, right? If you're doing it in a local system, you need a really, I think, a good configuration system.
Especially,
That's yeah.
yeah.
Else if you run it on a cloud, it's gonna cost you a lot.
Yes.
So with that, when you did mention Daniel about the NuGet packages, right? You can go ahead and install some of the NuGet packages, right? So people who come from the Python or R, what they would usually do is, for instance, they have this amazing library of pip. At least if I talk about Python, they have this pip that allows you to go ahead and add a number of Python libraries, maybe for visualizations, maybe for exploratory data analysis. That is really really helpful to go ahead and even start deciding which algorithm to use even before you train it, right? So how does that work in the ML.NET? So one has to, is there a good packages available in the NuGet package system, or someone has to pull it from
Yeah.
somewhere? How does that work?
Yeah, I will get maybe into more details later, the demo part. But ML.NET, it's more, it's modular. So it has the core in Microsoft ML NuGet package. And then some trainers are in some other package because you don't need all the time all the trainers.
Yeah.
For example, LightGBM. LightGBM, it's an additional NuGet package. Fast3, it's an additional NuGet package. It's modular, so you can keep adding more. For example, if you need to work with Onyx or TensorFlow, you have to add another additional NuGet package.
Okay. So it,
But
it
this
means
is keeping it very flexible, agile.
okay. Yeah, so we shouldn't compare it with like other Python or R, but I think it is mature enough to go ahead and provide you all the libraries and the package that you may need to go ahead and get started with your um, ML. I have a quick question that I just feel it right. So okay, so I think yeah, I think Daniel, before I ask that, do you have anything to go ahead and talk? Else, I would just ask any question that I feel. Anything you want to cover, follow along?
Okay, so do you want me to get into some? Please
Yeah.
stop me and ask questions
Yeah.
anytime
Sure.
because we are doing this for the audience.
Yeah. And it's not scripted, right? It's all going on.
Yeah, okay.
Okay.
I will switch back to the slides now.
Yes. All right.
Well, it's not easy to start with machine learning. I I saw that myself. It was so hard. It was like, okay, I want to do that. I understand a little enough to get it started, but something it's not right. I couldn't find the scenarios. I couldn't find, okay, I know in theory how I can use it, but now in production or in a real scenario, how I where I can put my machine learning. So why is that? We are so into the algorithmical programming, we don't even realize it. I have an interesting hypothesis for you. Has machine learning more human-like behavior than traditional coding? Think a little. Actually, it has. Let me give you an example. Writing an algorithm is like writing down a cooking recipe. So a recipe has ingredients, that's input data, and steps you have to follow to get the food done. That's output data. Well, but you or someone else, maybe from Stack Overflow or from CSharpCorner, did the recipe before, and the machine is only running it. Is the machine intelligent for running new recipe? Is this making the machine more human? No. Machine learning, on the other side, is inventing a recipe. Failing, succeeding, repeating until the recipe is good enough to eat it. This is making the machine learning more human than coding. We put our intelligence, aka algorithms, in the code, and that's pretty rigid. Why not to rely on the machine learning to create intelligence? Well, another question, is your algorithm adaptable by its nature? No, it's not. You're writing there and it stays. It's very rigid. It's frozen into your binaries. But machine learning, it's adaptable to data. We as developers have to be prepared for this new paradigm. I mean, machine learning, because in 10 or 20 years, it will change the way we code. But until then, we continue to write our own recipes ourselves. So again, why it's so hard to get into machine learning? Well, first it's the scenario to define your problem. Because when we have a hammer, all the things around us looks like nails. This is machine learning. We have to identify valid scenarios for our problem, because machine learning, it's like an extension for traditional programming. It's not replacing it. Then it's data. We have to get data, and we need data. When? Yesterday. We need data because no data, no party. We cannot think about machine learning if we don't have data. We have to have the data in advance. I like to say the data is the engine, not the fuel. Think about it. And then it's training. To build the training pipeline, it's another hard part. And remember that we are not, maybe, supposedly, we are not data scientists. So yes, building the training pipeline, it's a challenge. But maybe in this order: scenario, data, and then training pipeline. Well, Let's focus on scenario a little. Analytically speaking, we all know what to do with small data. It's easy to comprehend small data. It's easy to see patterns. But with large data, we are lost without instruments. Our brain is built like that. For example, images. We are not seeing images like an array of pixels. That's the analytical approach. We are seeing it in two-dimensional, three-dimensional arrangements, images. Our brain has instruments to see, the eyes, and to hear a picture, a movie, or a song, not to read the arrays of the bytes in it. And I like to make analogies. For example, machine learning is like intuition. What is intuition? For me, it's like finding the patterns in data. For example, you are in a jungle and you suddenly see with the corner of your eye a shadow falling on you. What are you doing? Analyzing? Running? Well, I think having the data you have, like danger of collision, unexpected, aggressive, yellow and black, well, 60% probability it's a tiger, so you better run. 60% is much, it's little, well, it's good enough to run and to do the analysis later. It's the same with the machine learning. We are not using machine learning for precise, 100% precise results. Your brain just runs a machine learning model with a significant score of danger when you are deciding to run because maybe it's a tiger. Actually, yes, you are running your own machine learning model. Now, this is a wonderful use case where the machine learning is very useful. Anticipating, guessing. So first, yes, we have to position, to place this paradigm in the right place. Machine learning, it's not like a universal panacea for everything. So why it's so hard to identify the scenarios for machine learning? Because we are used to think out the algorithms and to put the computers to work. This is a developer life, right? We are thinking in our mind, and then we are writing the steps. We are not putting the machine to think. We have to change that in order to use efficiently machine learning. As developers, we have to retrain our brain in that direction. So for that, we need an easy tool, an accessible and easy tool like ML.net, if we are .NET developers, and we need data. Talking about data, let's look at this. It's an artificial scenario. I have created for my demos so I can experience with them. These observations are labeled. So we have data like temperature, luminosity, infrared distance. This is data from sensors. And for this data, I make a prediction. The prediction, it's the label, one of these categories, flashlight, or lighter, or daylight, or infrared. So my set of readings falls into one of these categories. Actually, the source, it's generating, in reality, the source is generating the data for the sensors. Let me exemplify. We have a data set with readings from an IoT device, and we want to predict the category. So giving 20 degrees Celsius, 90% luminosity, 0 infrared, and the distance is 100 centimeters, obviously it's a cold light. So very probably it's a flashlight, not a lighter, not else. So as I said before, the data is the engine, not the fuel. We need more data, we need enough data. How much data is enough? Well, enough it's when it's solving your problem. So more data never hurts, as far as it's valid data. But data is the most important thing for machine learning. Machine learning model is as good as its data. The machine learning model cannot be better than its data, because data is creating the machine learning model. That means a bad data set drives to a bad model. Even more, it's more important to have good data set than having the most performant algorithm. Why is that? Because a bad data set will result in bad machine learning model. So you work for nothing. So if you think to skip data preparation, do not be surprised. You have to pay the price later. For that reason, I have called this, in analogy with technical debt, I have called this data preparation debt. Easy to remember. And then it's training. Traditional versus machine learning. Well, traditional programming is all about dropping some input data into an algorithm and get the output data. Let me show you this. In the right side, this is traditional. You have input, drop it along with the algorithm, and you get output data. Training, on the other side, it's relying on input and output data. And ML.NET, in our case, it's figuring out a function, an algorithm, good enough to solve our problem. But be very careful. And I give you an example. Let's suppose you have a line to measure distance, and you know nothing about summary or product, arithmetical operation, sum or product. And we are trying to figure out why it's these 2 and 2 resulting in 4. And you are trying, and you're starting to measure to see how long is this piece. Maybe it's 1.99, the other one maybe it's 2.2, but it's close to 4 something. Well, it seems to be, after many measurements, it seems to be the operations between these two, it's a sum. But if you are resuming to little data, like adding only the pieces which are analytically something like 2 and 2, you might end up, you need there a product, because 2 plus 2 is the same like 2 by 2. But if you have enough data, you will realize soon you will need plus or product, because 3 by 3, it's not 6, but 9. So this is maybe a trivial and naive example of how you can be tricked, but little data. You have to have enough data in order to get a valid model for your problem. Then the last part in the life cycle, when you are trying to consume a model, you find yourself in the same traditional scenario when you have some input data, drop the data into the algorithm, aka machine learning model, and you get the output data. So this is nothing new. That's why the largest part in machine learning is the training part. Let's take a look on this diagram I have created for a demo and for the presentations. We have the training pipeline, which is a pipe of transformers. A transformer is a component that takes that data, does some work on it, and returns the new transformed data, a transformer. And the transformers are by design lazy in order to accommodate large pipes, in order to accommodate large data manipulation. Then an estimator, it's an object that learns from data. That the result of the learning, of such learning, again is a transformer. So the estimators are eager. They are not lazy, they are eager. For example, fit method, which triggers the training, it's an estimator. It triggers the learning. And then the prediction, it's something which we apply. It's like applying a transformation on a row of data at the prediction time to get some score, some prediction. These are the instruments which we are using in the demo in a bit. Let me go to the demo, but not before telling you the prediction. So since we have the model, even if we just created it or we are loading from a previously created model, we are creating a prediction engine, dropping some input data, predict, get the output data. But fortunately, for this training part, we have the model builder. What's model builder? Well, to find the right trainer, we can ask a data scientist. We can get inspired by some by Stack Overflow or CSharpCorner, or we can use model builder. What model builder is able to detect which is the best trainer for a specific scenario. Each scenario has a catalog, associated catalog with a collection of trainers. So the model builder is trying these trainers and it's measuring the quality of the generated model builders in a specific time frame. The best score wins. Sometimes you don't need the fastest, sometimes you need the most precise, so it's up to you which one is better for you. So again, I'm not a data scientist. I'm trying to nail down the world of data science from a development perspective. Don't get me wrong, I'm not saying data scientist is not needed anymore. What I'm saying, you don't have to be a data scientist to get it started. You have model builder for that. You can later validate for production with a data scientist. And let's do some demo. I will create a completely new project, a console application. But frankly, I will not use this application. It's just a dummy project in order to get to the machine learning part. Simon, if there are questions, please let me know.
Yeah, Daniel, there are a few questions. Let me know you want to take it. You can take it now or
Okay,
maybe after the demo.
now I will take them now.
Okay.
I will switch to the, so I can see the question myself. Okay,
Oh,
okay,
fine.
just,
Okay, you're back, right? So, okay. So, the first question is coming from Arjun, right? He's asking that this is a good question. That is it possible to work with TensorFlow and ML.NET at the same time? Can we just bring them together?
TensorFlow as a model, it's
Mhm.
um, compatible. I think ML.NET is able to consume TensorFlow models. But
Okay.
if you plan to train from scratch,
Hmm.
you have another framework developed by a Microsoft team, and it's called TensorFlow.net. If you search for TensorFlow.net, you'll get it there. And that's even more, it's compatible um, by naming convention with the
Hmm.
Python library. So for someone who used Python before, it's easy to migrate to .NET. Even more, ML.NET deep learning part, it's built upon TensorFlow.net. So
Okay.
they are, it's a dependency.
Okay,
Yeah,
that's
cool.
great. So they're both the options. Either you can go ahead and either consume it or maybe just build on your own using this TensorFlow.net library that's out there, right? Okay, so we'll take one more question. Okay.
No,
Then
no, no,
then we can
just,
move to demo, right?
yeah. Okay, no, you can follow with the, can we edit the code generated by model builder? Yes, okay, let me show you. This is
Okay.
exactly what I'm going to demo. I will zoom in. So we have to right click on the project, hit add, and then machine learning. All you have to have is the data. So these are the scenarios which are covered by ML.NET. I will not get into the details because we don't have time. So I will choose multi-classification, which is the first one. For now, I can train with CPU, but for some scenarios, GPU is available as well. So I will hit next because I want to load the data. I have a data, as I said before, no data, no party, but I have the data with about 1000 readings. So I'm selecting which column I want to predict. And this is the source, the light of the flashlight, one of those categories. And I will hit advanced data options because maybe I want to fine tune the type of the features involved in the model builder. What's detected? Temperature, it's a numerical field, which is correct. All of these are correct, but for PIR, it's 0 or 1 because it's detecting if it's a human presence or not. So I leave it categorical. But for humidity, I know it's numerical, but maybe I have too little values and it's mistakenly assumed it's categorical, but it's not. It's numerical. And I don't need this field created at because it will not help me get a better model. Uh, Daytime fields are better for forecasting, not necessarily for such scenarios like multi-classification. So having this data, I will hit next. I will put, for example, 20 seconds time for training. Um, is it enough or not? There is a help here. It will advise you how long it's advisable to train, but make sure it's enough. You can try with larger intervals. So now what's happening here? Model builder, it's trying the trainers from a category, and okay, I will give 30 seconds because obviously for me, because I know already, we didn't have enough time to detect too many trainers. We can see below the micro accuracy, the macro accuracy, and the duration. Just a few seconds and we are close to get what we need. Okay, next step. We can even test to make a prediction for some randomly generated. Actually, I think it's not randomly, it's the first row in our data set. And then I hit add to solution. In this way, I'm answering the last question. If we are able to modify the generated code. Yes, we are able to modify by hand after this is generated. Even more, I didn't install yet, but we are able to persist these steps in a JSON file, and we can keep track in a history the results of building, of experiencing with this. But I will show you what we got here. I will create this console application generated because this is part it's consuming. Actually, this part is predicting data, but not before having the model built. Model input is generated by the ML.NET, and it's the corresponding one-on-one C# object for our head in the CSV file. We can see here, for example, PIR is string, but the other, which are numbers, numerical, are float. And the most important thing, in the consume models, there is not right there, model builder. This is the training pipeline. This is the training pipeline. We can see here the source, it's transformed from string to number. And then the PIR, which is categorical feature, it's transformed as well into number. And then all of them, now being numbers, are concatenated in a composite feature. This feature, it's sent to the trainer here, to the light GBN trainer. And then this is mapped back to a predicted value. And voila, we have the training pipeline. But now, this is something which is kind of autopilot, which is not the best we can do. And for that, I want to show quickly in a few minutes what we can do to get a better model. And for that, I will introduce you very quickly to Jupyter with .NET kernel. Maybe you are familiar if you are working with Python, maybe you are familiar with Jupyter, but now Jupyter is supporting .NET. And it's supporting C#, it's supporting F#, PowerShell, HTML, JavaScript, SQL, and we are expecting more. So what I have here, we can copy and paste from our generated source code. We can paste here the pipeline. I have cleaned up a little, but what I want to show you, we can run all this and measure the quality. So on autopilot mode, the model builder it's building a model with this accuracy, 91.64. But if we want to go an extra mile, we should do that. If we want a better model, we should try to make it better. And we have some instruments. Grace to Jupyter Notebook, we can use this in a very visual way. So I will run this. I will go fast over this. For example, we can check how are our data distributed by categories. We don't want unbalanced data. If we have highly unbalanced data, we have to do something related. I have another presentation which is addressing, actually 6 months ago, I had something focused on data preparation. So there, if you can, you can search on YouTube and check how I got into details analyzing and preparing the data. But what I want to see here is we can analyze data and decide if we want to keep all the features or we simply don't need them all. Because obviously our impulse is to give to the trainer pipeline all the data we have, but obviously not all the data is bringing value. So we have to decide which data is relevant, which is not, because the not relevant data we want to remove. Or something else. Having too many features has a direct impact on the dimensionality of our model. So reducing this dimensionality results in a faster model. The performance is important. Many times we need real-time predictions or near real-time predictions. So this is important. But analyzing by features, correlation metrics, we can see which features are having direct impact on another features. For example, if two features are very similar, they are varying together, they are rising in the same time or lowering in the same time, very probably they are redundant. We don't want to keep them both, so we can remove one of them. For example, we have two temperature sensors very close in the same system. So maybe we have that for redundancy, but we don't need to measure both because it will increase the dimensionality of our problem. Then another thing we can do, we can measure the permutation feature importance. What we can see here, it's the temperature, luminosity, and infrared have the biggest impact on our model. This distance a little, but definitely PIR and humidity are not bringing value. Even more, if these values are less than 0, it's negative. We have here like a lucky guess. So our data, it's doing lucky guesses. Definitely, it's not something we want to keep. So let's remove these features from the lower part and see if our quality of the model increase or not. Okay, I will load again and take a look. I keep only temperature, luminosity, and infrared. And we will measure again. And now it's almost 93. So it increased from 91.64 to 93. It doesn't look much for our case, but it can be very important improvement. And sometimes a few percent are very important. I will not go further with this demo because it's not the scope of this talk. I wanted to exemplify how we can improve, but we don't need to. We can, to have a faster jumpstart, we can rely on model builder. And my advice is just start it. Just start to play. It's something, it's a skill you want to add to your skills, and it's something complementary. We cannot avoid the future. It will hit us sooner or later, and we want to be prepared. I have some resources which I recommend, but meanwhile, I want to get some other questions. So Simon, if you have something, just let me know, please.
Yeah, that was great, Daniel, and I really loved the entire step by step where you go ahead and they talk about it. And also, I did like that you did mention that Jupyter is now available almost everywhere. It's not just in Python or C++; it's also in the SQL. They call it more like a data studio. And the amazing part, even inside the data studio, you can go ahead and run Python version. It's also in the .NET, and I believe it's coming. Everyone is going and actually adopting this Jupyter notebook, which is pretty handy. Export as HTML or a PDF. That's pretty easy. So we have one question. I think we have a few questions actually. Let's take maybe from the top as you're running a little over time. Sitaraman is asking, can ML.NET be extended to run models from other source like Runway ML or generative deep learning models like CycleCans from other sources?
Yes, let me tell you how. ML.NET is working with native, it has its own native format. But in addition to that, it's able to consume, for now, to consume TensorFlow models that's in protobuf format or it's .tf, and it's able to consume ONNX models. Well, ONNX format, it's a portable. It's supported, developed by Microsoft and Google, supported by Amazon and all bigger players. So it's kind of becoming a standard. So as far as you can export your model in whatever framework you like, if you are able to export it in ONNX or TensorFlow, at least in theory, because maybe there are still some incompatibilities. I cannot get into details, too much material. But in theory, yes, it's able, and there are a few examples over the internet and on the official websites where YOLO model developed with I don't know, it's Keras maybe.
Yeah.
It's consumed in with ML.NET to make predictions, and it's inception model from in TensorFlow. Inception model is another popular model which is able to do image recognition.
Yeah.
But there are more. And I recently played with ArcFace, which is face recognition. But as I said before, ML.NET it's still evolving, and it's not covering yet all the data types or the all the parameters which are available in the original framework. I'm hoping it will be compatible with everything soon, and at that point we'll be able to consume any TensorFlow model.
Yeah, I think it's only been 2 years, and Microsoft has been investing a lot in this ML.NET, and I see community growing a lot. And in any of the major conferences, I see Microsoft coming up and giving us some more, if not major, some minor releases. And yeah, so I think with that, there's also one question that definitely answers is that you did mention about YOLO. So yeah, so he asked, can we run YOLO on this and get object location on this? I think pretty much same approach.
There is a Tiny YOLO version 2, which is the official sample. But if you take a look on my PowerPoint, there is the Rubik's Code blog, and one of the latest articles, it's consuming YOLO version 4 which is detecting 80 classes instead of 20. But it's not limited to this. So the answer is yes,
Yeah.
with a few versions, but it may be anyone who can figure out how to set the hyperparameters for any YOLO models and other
Okay.
models.
Okay, Daniel, you did mention about you did write this in your blog, so maybe if you could give your blog link in the private chat, I can put in the comments that people can also go ahead and visit it later on. Now before and why did you do that? This is a pretty interesting question, and I think I know we are already over time. The static world would ask, can we use it in Unity 3D? And the reason I feel he's asking is that in the Unity development, you actually use C Sharp. Earlier it was C Sharp, JavaScript, and Bool. And I think Bool is gone, so I'm not sure about if JavaScript is still there or not. But we use definitely C Sharp in the Unity. So you think we could somehow tweak in and use ML models in the Unity or
The,
some any
the,
other application that
yeah.
allows C Sharp development?
ML.NET it's built on .NET standard, so it's compatible with anything. And I could see some WPF samples consuming, training and consuming. I can tell Unity 3D it's compatible as well, but I have this I didn't see it in work, so
Yeah, yeah,
it's
yeah. But
I'm
it's something to go ahead and explore, maybe, right? So yeah, because people write like C Sharp for the Unity. I know. Let's take maybe last final one, then we'll wrap it up. We'll just could you talk about it's called Sci Sharp or C Sharp? I don't know. Sci Sharp. I think we have given the link in the chats of the GitHub, so I think you could go ahead and maybe
yeah.
learn a lot more about that from there.
Yeah, CSharp it's an umbrella for more technologies which are dealing with porting uh, Python libraries into .NET. I didn't work directly with these libraries, but the good news, they are supported in C Sharp, so you don't have to import Python code into your solution in order to use it. I don't know how much of it is compatible, but I know it's a very nice job in it's getting mature,
Yeah,
and
yeah.
it's in development.
Okay, so Daniel, I think that that's how we would wrap, right? I think we're only 3 minutes over time. Before we wrap, any final thing you want to say or something about the all people who join or something?
If you could switch again on my last slide on PowerPoint.
Yeah, if you just move it to your slide and then add it to the screen.
Oh, sorry, that's right.
Yep, there we go.
Okay, let me conclude then.
Yeah.
ML.NET, it's not aiming to replace existing frameworks like TensorFlow, Keras in Python or whatever language. But considering the AI is going to be adopted by the majority of the applications, as .NET developers, it's good we have an in-house alternative for doing data science, machine learning. And myself, I prefer this code-first approach and the fact I can develop in my daily language like C Sharp. And in addition, ML.NET, it's easy to learn, it's fast, it runs on premise, on different platforms, it's open source, you can contribute. I do not refrain you from contributing. I have contributed myself, and it was the first contributions. I was very shy starting, but because being a work in progress, you definitely can find something to contribute on different levels. And for the future, the Blazor has support for inference or prediction for now, but for training, it will be supporting we will support it very soon. It was not easy because the JavaScript limitation to single thread model. And then very soon, we will get support for, very soon means hopefully when .NET 6 at most, when .NET 6 will be released, it's my feeling. We will have ARM CPU support for training and for prediction. Personally, I'm very excited because the Raspberry Pi and the Apple M1. Actually, I decided to buy an Apple M1 with ARM CPU for more reasons, but this is maybe the most important. I'm a geek.
Yeah, Daniel, you're definitely a geek, and all of your slides are really amazing. One final question again. I keep on saying final question, Daniel, but one apart from all this, ML, data science, AI, C#, .NET, community stuff, speaking in live shows and conferences. What are your hobbies? What is something that you do apart from all this?
Well, I have a little daughter, so I cannot go outside for my runnings or stuff. So I have to be very careful with my spare time. Well, I'm programming Raspberry Pis. I have this guy with me.
Wow, that's great.
This is a camera, proximity sensors, luminosity, temperature, LEDs, and I'm playing with this sometimes. But mostly I'm preparing for the next talk and the next talk, and this is taking most of my time.
Wow, that's great. I love that you put the ultrasound sensor at the very right place. So that's
because I want to feel some familiarity. I humanized my bot.
that's amazing. I wasn't expecting that to come. So thanks, Daniel. That was an amazing session. So really loved it, and I believe there were quite a few questions. So thank you everyone who joined us today. You can always go back and watch the session on csharp.live or CSharpCorner YouTube channel. Everything is available on demand and it's all archived. So thank you so much, everyone. Yeah, thanks, Rijwan. Yeah, really loved it. Yeah, thanks for that. Awesome gadget. People love that.
Thank you again for having me, and I wish you a very good day, and thank you very much.
All right, thank you, everyone. Thanks, everyone, for joining. We'll see you next Thursday, same time, and see you soon. Bye-bye.
See you soon. Bye-bye.